Good afternoon, and welcome to NASA and Firefly's post-mission news conference for Blue Ghost Mission 1 as part of the agency's Commercial Lunar Payload Services, or CLPS initiative, and Artemis campaign. I'm Natalia Rusak with NASA Communications. On March 2nd, Firefly's Blue Ghost Mission 1 landed at Mare Crisium, a basin on the near side of the moon, delivering 10 NASA science and technology instruments. Named Blue Ghost, the lander completed approximately 14 days of surface operations on the moon and operated for multiple hours into the lunar night. Here to talk with us about the Blue Ghost mission, as well as the NASA Science and Technology, are Joel Kearns, Deputy Associate Administrator for Exploration with NASA's Science Mission Directorate, Jason Kim, CEO of Firefly Aerospace, Ray Allensworth, Spacecraft Program Director for Firefly Aerospace, and Adam Schlesinger, Commercial Lunar Payload Services Project Manager for NASA. Before we go into our opening remarks from our briefers, we have two images captured by Blue Ghost right around the lunar sunset. Let's take a look. The bright light in the center is the sun, and the bright light above the sun is Earth. And the bright dot in between them, out in the distance, is Venus, as identified by Firefly. And here's a view of the lunar sunset looking to the west, taken from a different camera. We're looking forward to the analysis from science teams once all of the images have been reviewed. Thank you to Team Firefly for having these photos ready to share with us this afternoon. After brief opening comments from each of our speakers, we will take your questions. For those of you in the room, please feel free to raise your hand to ask a question. For those of you on the phone bridge, please, you can enter *1 on your phone to be entered into the question queue at any time. The operator will unmute your mic when you're up and close your mic after you ask your question. We ask that you please stick to one question for now and identify to whom your question is directed. Shortly after we conclude, you can watch a recording of this news conference online. First, we will hear from Joel Kearns.
Thank you, Natalia. Well, first, at NASA Science, we're incredibly pleased with Blue Ghost Mission 1. Both in the outcome of the mission and also how well the Firefly and the NASA payload teams work together to achieve something new. America has now explored a new region of the moon that Americans have not seen before. I think that Firefly Blue Ghost Mission 1 is what I would call an existence proof of how we wanted commercial lunar payload services to work. In this case, NASA contracted with U.S. industry, Firefly, to take NASA's science and technology payloads to the surface of the moon, operate them, and bring our data back. Firefly put together a mission, designed and built and flew a lander, and accomplished those objectives for NASA. These are all done as part of our Commercial Lunar Payload Services initiative, part of NASA's Artemis campaign to prepare for human exploration of the moon and a long-term human presence. We also, in addition to accomplishing many scientific objectives for each of the payloads, we got additional science working with Firefly during the sunset and during the lunar nighttime period where the lander was still operating. Now, operating on the moon can be very complex during the long lunar day, the long hot lunar day, and the 10 payloads on this mission were a larger number than we'd flown on any other CLPS mission to this date. And all those payloads were afforded extra opportunities to gather scientific measurements than what we had originally envisioned. The reason we're working with U.S. industry is to exploit the entrepreneurship and the technical innovation of these U.S. companies working with American industry to accomplish public goals. Now, what we've asked industry to do, that is, land and operate on the moon's surface, is not easy. It's extremely difficult. We've talked about this in the past. It's really difficult to do this with robot systems. And NASA is very good at doing robotic science probes. In CLPS, American companies are using their own engineering, their own technical ability, instead of adhering to normal, formal NASA practices, flying their own missions to the lunar surface. One thing I want to share was what I observed in the mission operations at Firefly, the excitement in the room between the science teams from NASA and the spacecraft developer at Firefly as each new achievement was completed. It was really contagious. Every time a new operation was conducted or a new milestone was reached, both teams were cheering each other on. It was a real demonstration of how NASA and commercial companies are working together to explore these new regions of the moon and make them accessible for the United States. Let me turn over to Jason. Jason?
Thanks, Joel. I forgot to do a chest bump with you. You got me so excited. Firefly Aerospace is extremely proud to have accomplished this first fully successful commercial moon landing on the 2nd of March. We've since completed 100% of our mission objectives after more than 14 days of surface operations, marking the longest commercial operations on the moon to date. This Firefly team continues to raise the bar and make achievements that are incredibly, these are incredibly difficult things, but, my team makes it look easy. They continue to, raise the bar, but make no mistake, like Joel said, there was nothing easy about this mission. I think that you heard our chief engineer confidently say, y'all stuck the landing and we're on the moon. And shortly after that, the team finally got to celebrate, but instantly they went back to operating the payloads and collecting all the science data and beaming it down to the Earth. And since then, we got all 10 NASA payloads to collect all their science data. And as a bonus, we were able to capture the solar eclipse and then subsequently the solar sunset. And then what we see as the glow phenomenology looks very similar to what I've seen other astronauts put only in notes. And it does look green. I want to just take this moment to frame the gravity of these accomplishments. When this small team of Fireflies started in 2021 on this program, they had never built or flown a spacecraft before. This was their first shot, and they took Blue Ghost on a 45-day orbital journey, landed stable and upright, and operated her for more than 2 weeks on the moon. So that's incredible. Achieving these milestones on the first attempt is a feat that even eluded nations. Firefly proved that space exploration is limitless, even for the smallest of teams. And if you dream big, innovate, and execute, you can land on your goals. Congratulations to this bold, unstoppable team of Fireflies. You nailed this historic mission. And thank you to NASA and the White House administration for creating the Commercial Lunar Payload Services Program. It truly is a best practice in the government. It allowed us to, be innovative and unleash the commercial capabilities that Joel talked about. And this mission marks a pivotal moment in history. It's inspired millions of people around the world. I truly believe Firefly's Blue Ghost historic mission will be a new chapter in textbooks and become a beacon of what humanity can achieve. Over to you, Ray.
Thanks, Jason. I really want to take us back to when we were awarded Blue Ghost Mission 1, and we really wanted to make a commitment to NASA to carry all 10 of these NASA payloads to the lunar surface. And I'm really proud to say that we were able to accomplish that goal and take all 10 payloads with us to the lunar surface and accomplish, just such a significant amount of, mission objectives, science objectives, and really just kind of maximize that value for NASA and then all these individual payloads that we had on board. Over the last 60 days, the team, has really maximized the time spent in transit, and then ultimately, landing softly and safely on the lunar surface. We were able to completely maximize the lunar day, operating every day that we were on the surface, and as Joel and Jason mentioned, also through an eclipse and into lunar night. And it's that data that is really important to us as Firefly to provide back to the payloads. We collected over 119 gigabytes of data, and that's imagery data and payload data. That doesn't include even the telemetry data we brought back down. So just a significant amount of data now that all the teams get to go dig into, learn from, and I think over the coming months and years, we're really going to see, just all the information and new findings coming out of all this data. I really do want to attribute our success to our Firefly team. They're just a really incredible group of engineers, technicians, support staff, these men and women that have supported this mission for years, and their families that have helped make this a success. So I think they really approached this mission from a really, unique point of view. We really managed risks. We really tried to, come up with the safest and reliable way to get all of our payloads and get as much data back as possible. So I just want to say thank you to the Firefly team and also thank you to NASA. It's been amazing partnering with y'all. You were in the mock with us through the whole mission as well. So just thank you to y'all, and we look forward to going through lunar night. We don't expect to survive lunar night, but nonetheless, in the kind of we're all engineers, we're all very curious, so we are going to try to turn the lander back on after lunar night, and so we'll check back in early April and see if we can, get any more data. Back to you, Adam.
All right.
Yeah.
Thanks, Ray. Yeah, and similarly, I want to start off by thanking you both and congratulating you and the whole Firefly team for the outstanding mission and a very successful mission. I also want to thank the NASA Eclipse team and the payload teams, as you mentioned, helped contribute to the mission success and also benefited from the mission success. I think the success of the Blue Ghost Mission 1 mission really further validates the Eclipse model, and that includes the technical, the cost, and the schedule aspects, which is very important. As we mentioned, all 10 NASA-sponsored payloads successfully were activated, collected data, and performed operations on the moon, which is a big feat. And as you mentioned, you kind of took that all on from the very beginning, so very happy to hear that. And many of those instruments, as you allude to, also operated multiple hours into the lunar night, which is also very important and very impressive. As Joel mentioned earlier, a lot of the initial results that we received are very promising, but we're still kind of going through all the data and processing it. But we're very excited for what we're expecting to find as part of that broad set of data. And you mentioned the gigabytes of data that came down. So we're continuing to go through that and really looking forward to what we're going to see. I wish I had time here today. We're limited to just the hour for the press briefing to talk about all the specifics of each of the payload operations during this mission, including the many accomplishments. But I will point you to the Artemis blog and the end of mission briefing that should have just went out that kind of highlights a lot of those accomplishments for each of the 10 NASA-sponsored payloads, including some amazing imagery and video that's come down. That's been one of the big success stories of this mission. I've been able to show those images with family and my kids, and it's just the inspiration that they provided is great. So that's amazing, and we really value that. Even with the success of the Blue Ghost Mission 1, there's always opportunities to kind of get the lessons learned and apply those to future missions. We have had things on this mission like better understanding of the transit in the lunar environment. We've had better understanding of how hardware performed versus previous expectations. We've also had, actual operations for over 2 weeks. That's the first time we've had to do this from Eclipse delivery mission perspective, and that's something that we're going to learn from. And I know that's a big objective of the Eclipse model. We take those lessons learned and we apply them to future missions. I know Firefly with Blue Ghost Mission 2 and Blue Ghost Mission 3, we're going to do that as needed, which are targeted to fly in 2026 and 2028 respectively. But also, as applicable, we can apply those to other Eclipse deliveries as well. So I want to say congratulations again to you and the Firefly team, and I hope and look forward to continued success for Firefly's Eclipse deliveries as well as the other providers as well. Thank you, and back to Natalia.
Thanks, Adam, and thanks to our briefers for those initial remarks. We'll now open it up for questions. Again, if you are on the phone bridge, please press *1 to submit a question. Once your name is called, please state to whom you'd like to direct your question. If you find that your question has already been answered, please press *2 to withdraw it. Let's start with a question in the room before we head over to the phone bridge.
Gina Sinceri for Ray or Jason. Did Firefly do anything where you went, wow, I didn't know it can do that, and what was it?
You can start. I'll go after you.
That's a really good question. I think kind of Adam hinted on it during his statements that we really learned a lot. I think one of the things I like to point to a lot is the amount of thermal data and the thermal environment that we lived through. Some of the components of that were unexpected, and the team was, they needed to adjust and they needed to learn and work through that. We knew lunar noon would be happening, but we didn't initially understand how the interaction of the sun and the craters would work. So the team kind of live took that data, updated models, and applied it forward. So stuff like that, I think, is a really good example of what we were actively learning on the lunar surface, and that we'll be able to apply moving forward.
From my perspective, we're a rocket company that evolved into a end-to-end, fully integrated space company that does lunar landers and satellites as well. And what really impressed me is that Spectre engine that we build in-house and how perfectly it performed. From my lens, never had to do a makeup burn, and there were at least 7 major burns that Ray and team had to operate through, and every one was like clockwork. I mean, every one was like precision down to sometimes near 0 millimeters per second delta V precision, and then because we had that 45-day pragmatic approach, not only did we get tons of data before we even descended on the moon. I think it was like 60 gigabytes before we descended on the moon, and we tested out Lou Gray and RadPC and others. But it also gave us a chance to take our time in lunar orbit injection 3. And what surprised me was the team said, hey, we want to get mass properties nailed down before we, let the lunar lander do its thing by itself. And so, I think the consensus was everybody said, hey, let's take this opportunity and do that. And so I saw the team just very mature, very disciplined. It was like someone, took a team that has done this forever and put them in our mock, but this was the first time they did it, and I'm just really impressed with our team.
Let's take one more in the room before heading over to the phone bridge.
It's Mark Strassman, CBS News. One for Ray and then one for Jason. Ray, was there one moment that stands out as the most tense or dramatic? And then Jason, for you, what does the success of this mission do to help establish a foothold for this emerging lunar economy?
Yeah, I'll start. There are definitely a few moments that were kind of this like hold your breath, I might pass out like moment. I do think landing was the most kind of like tense, like maybe the most intense moment of the whole mission. And it's also because, I think we've talked before that landing was autonomous. So it was also this moment where you kind of give up the reins, you give up some control of what's happening, and you have this, 12 and 13 minute period where you're just waiting, and data is coming at you and you really can't do anything about it. So that I think was the most intense for the team, but then it was also the most joyous after to find, you see those sensors light up, you get that telemetry data back, and you realize that, we're in a perfect condition, great orientation, exactly where like the safest place to go. So like, just intense moment followed by just kind of an equal amount of joy. It's probably the biggest one for me.
Yeah, Ray kept her cool the whole time. I was just so impressed.
I looked like I was cool. I don't know.
Mark, we didn't just get our foot in the door. We got all 4 feet fully planted on the moon surface, stable and upright. And so I think what that does is it really just validates our company model of doing good designs, very exceptional engineering, lots of testing of components and subsystems, and the entire system validates that mission assurance kind of methodology, as well as all the simulations that we did and rehearsals that we did. So we validated our mission operations team. And also the 45-day pragmatic approach to the moon that really validate that that's kind of the Goldilocks approach of not too fast, not too slow, just right. And so what it does is it gives everyone more confidence, including our customers, both on the government side and commercial side, that we could do it again on Blue Ghost 2. And we can take the lessons learned from Blue Ghost 1, make Blue Ghost 2 even more successful. Same thing with Blue Ghost 3. All those lessons learned apply. Good, bad, ugly, they all apply. And then, we're getting a lot of inquiries from the commercial side as well. And so, people have business models and revenues that they have to generate. They can depend on Firefly to take a very pragmatic approach and stick that landing and ensure that you get multiple days of surface operations.
Thank you. Let's head over to the phone bridge for our first question from Kenneth Chang, New York Times.
Hi, thank you. I was wondering if Dr. Kearns or perhaps another scientist who might be there could comment on the sunset photos. It looks like there's a glow. What can you tell about that, perhaps, and does it match with what was seen previously? Thank you.
Well, we're going to be taking time to have scientific specialists go over all the imagery from the mission, not just the sunset and the darkness photos. But one of the things that they will be looking for in some of the imagery is to see if they can identify a phenomena called horizon glow or a mechanism called dust lofting. So lunar dust particles can become charged due to exposure to the solar ultraviolet radiation, and these particles can experience what we think is electrostatic repulsion, causing them to lift off the lunar surface. That's the model. So the thing that has been observed by robotic probes and reported by astronauts in the past, in the 60s, called Horizon Glow was identified in images from the NASA robotic spacecraft Surveyor 5, 6, and 7 in the 1960s, and that may have been caused in part by sunlight scattering through a cloud of electrostatically lifted particles. Now, it's going to take some time to go through these images, but what I'm really happy about is that these images, I think, are the first high-definition images of looking at sunset and transitioning into the dark. So this is going to provide a valuable opportunity for not only the scientists who are on this mission, but general members of the scientific community to look at what's in the images and compare it to some of the perhaps complementary measurements made by instruments on the mission. So, for example, we had an instrument, LMS, that was looking at magnetic and electrical fields on the moon. Researchers may be able to look at some of that data or look at some of the data from the RAD-PC computer test, which was also looking at radiation effects on the moon, and correlate it perhaps to what's available in those images so that we will be able to use these high-definition images such as that one for additional scientific findings, we think, in the future.
Thank you. Our next question from the phone bridge is from Jeff Faust with Space News.
Hey, good afternoon. A question for Ray or Jason to get back to the question about lessons learned from Blue Ghost 1. Is there anything that immediately stands out that from Blue Ghost 1 that you plan to apply in terms of hardware or operations to Blue Ghost 2 and 3?
Yeah, it's a great question. I do want to reemphasize that the thermal data is definitely the most applicable, particularly because of the presence of craters more substantially in other areas of the moon. The South Pole is a great example of a place that has a significant number of craters, and it will really significantly impact how spacecraft, any spacecraft, ours or, other NASA missions interact and survive those temperature conditions. So that's definitely a really big one. There's other ones that we've already looked at and we, in some cases we've already incorporated into future missions. A lot from like our integration and test phase, we've already begun capturing those lessons learned and incorporating them into the design of future missions. There's also some ConOps improvements. We're actually going to meet with the team in about 2 weeks and do kind of a full mission operations retrospective. For that purpose, we really want to review, what went right, what went wrong, what do we want to change, what do we not need to change. So we'll really do kind of a full deep dive and figure out, what worked, what didn't, and how to apply that moving forward. So I think that's definitely a big kind of conversation that's going to happen in the coming weeks after, we all kind of take a week or two off and, take a break.
Thank you. Our next question is from Stephen Clark with Ars Technica.
Hi, thank you for taking my question. I think my question is probably maybe for Jason and one of the NASA reps, Joel, perhaps. You mentioned this is a proof of the eclipse concept, proof of concept for eclipse at the moon. There have been studies last year about kind of extending this way of doing business to Mars. Any thoughts about applicability of either the Blue Ghost design? I know landing on Mars is very different than landing on the moon, but from Firefly's perspective and from NASA's perspective, what's the status of those commercial Mars studies? Thanks.
Did you want to start first?
I'll start. So NASA published the end of last year our plan called Mars Future, which talks about future activities we think will be accomplished by NASA's Mars exploration program, in addition to one everyone hears about often, which is Mars Sample Return Program. And one aspect of that is to employ potentially commercial services similar to the way we've done with CLIPS, but for in-orbit or in Martian space, or even someday potentially Martian surface services to be provided. So again, NASA is not having to develop spacecraft or infrastructure all itself. I think that Mars is a different place than the moon is, much further away, has an atmosphere. Moon doesn't have an atmosphere. But I think that we will be looking in NASA science, we're going to be looking at how CLIPS progresses to try to figure out how the lessons of CLIPS could be used for other activities we do in space. And even the National Academy of Sciences Decadal Survey for Planetary Science and Astrobiology in 2022, called Origins, Worlds, and Life, recommended to NASA that if CLIPS is successful, that we try to figure out how we can transfer the way of doing business and the lessons we learned with Eclipse for scientific studies at other destinations in the solar system.
Yes, I agree with everything Joel just said. I'll just add and remind folks that we're in the very early innings for CLIPS in general. So I told our team, earlier this week, we have more task orders in front of us than we have behind us, and that goes for missions for Firefly as well. We've got 2 already planned and just a successfully executed one. But as Joel indicated, everything we're doing for CLIPS on the lunar surface, both from the spacecraft development and what we learn on the surface itself, is extensible, and we hope to leverage that within the different initiatives that Joel referenced. Yeah. Sorry, go ahead, Jason.
Yeah, Stephen, we have Firefly, we have a great culture, a very pragmatic strategy, and doing landers outside the Earth is something that is in our strategy. And we have exceptional engineers, as you can see, and we're rating up our manufacturing and expanding, as you know. So I don't see anything that precludes us from doing moon missions and Mars missions.
Thank you. Our next question is from Andrea Leinfelder with the Houston Chronicle.
Hi, and thanks for taking my question, and congrats on a successful mission. Ray, could you tell us how precise your landing was, and what hazards did Blue Ghost autonomously avoid before touching down? And then I think this one's for Adam. Why did Lister only drill 3 feet into the moon? I believe it's supposed to go nearly 10 feet. Thank you.
Yeah, I can get us started. So we landed slightly outside of our ellipse. We kind of had a 100-meter ellipse that we were targeting. Our onboard navigation software did 2 hazard avoidance maneuvers that took us about 58 meters outside of that ellipse, because that ended up being the safest place for us to land. And that is ultimately the highest priority. I think the main goal was to land in Mare Crisium, that type of structure, geology on the lunar surface, but ultimately to land softly and upright. So we did pick a spot that was outside of that ellipse, and then once we picked that spot, we landed within 1 meter of that spot. So our accuracy was very, very high once we picked the safest location at Mare Crisium. And I'll let you speak to that, Lister.
And thanks for the question. Yeah, with respect to Lister, I will say, and you are right, it did drill to about 3 feet deep, and I will say that they got as deep as they could within the operational opportunities that they had. I think they ran into some challenges and kind of probably expectations that were different with respect to the surface and what lies beneath. But again, they had multiple attempts and went as far as they could go. I will also point out that that was the deepest robotic planetary subsurface thermal probe to date. So that's a big accomplishment for the Lister payload and a first of its kind demonstration. And also note that they took thermal measurements, including during lunar night. So they were one of the payloads that were operating during night, and that's also going to be very valuable information moving forward.
Our next question is from Irene Klotz with Aviation Week.
Thank you, and congratulations. I have 2 questions, both on the business side of things. For Joel or Adam, is it possible for Firefly to earn more than $102 million that was allocated for this first mission? And is there a division of data owned by Firefly, or does NASA own all the mission and science data from this? And then for Jason, specifically, have you signed any more customers for Blue Ghost 2 or 3 since the Blue Ghost 1 passed enough of a time on the moon to where you could call it successful? Thanks.
Yeah, so with respect to the contract, there were options built in, specifically to the contract, and we know we worked well into one. We're going to have to work through the kind of the details there, but we are very confident that a lot of that option was met, but that'll be worked. And with respect to the data, we have a contract that outlines, what the rights are there, and for anything additional and out of that scope, we're going to have to work directly with Firefly. But as we talked about already, there was so much data that was collected as part of this successful mission, and we're interested in so much of it. So that's just something we're going to have to work through. But yes, there is potential there.
Hey, Irene, like I said before, we're getting a lot of inquiries. Since we're a private company, we hold our wins, proprietary. But when we can announce things, we'll be able to announce then.
Thank you. Our next question is from Will Robinson Smith with Spaceflight Now.
Hi, thanks for taking the time to speak with us. And again, congratulations on the landing. Question to either Joel or Adam regarding the eclipse that was observed. Beyond just being sort of a point of fascination and inspiration, is there additional science data that can be gathered by observing an eclipse on the moon that, other instrumentation that is used to do a similar phenomenon here on Earth or in Earth orbit cannot do? Thanks.
I'll start and ask Adam to come. So obviously the images will be studied closely, but in addition to that, the individual scientific investigation teams for the payloads will be looking at the effect of not having the solar radiation during the eclipse, at the same level, being measured by the payloads, how some of the local environmental conditions might change. If it's not being illuminated, the temperature might go down. Making sure that they can try to infer things that what maybe affect the measurements or shed some light onto things related to that eclipse. I think it's going to be up to the science teams to go figure out what they can draw, but I know they were really happy to be able to take data during that period, the payloads that were able to take data. Adam?
Yeah, the only thing I'll add, you mentioned the charged particles, and we had the eclipse, not too long before, the sunset. So understanding how the potential charging of those particles change with the eclipse and going into the sunset, I know that's something that's been identified and something that we'll look at. The other aspect I'll mention is not really scientific, but more to what Ray had talked about previously with respect to the thermal environments, how that eclipse, impacted the thermal, on the surface at the location that we were at to kind of help inform the models moving forward that will be beneficial for future missions.
Yeah. Thank you. Our next question is from Issam Ahmed with AFP.
Hi, thank you for taking my question. I was wondering if whoever feels it's appropriate to talk a little bit more about those lovely images we saw at the top of the call and what we're seeing there. And for Ray, I think you mentioned trying to turn it back on after the lunar night. What are you sort of rating as your odds of success for that? Thank you.
Joel, do you want to start with the images that were shown, and then I can, or do you want?
Well, I guess all I would say about the images, and others should also add, is that these are the first high-definition images, taken of the sun going down and then going into darkness at the horizon. So we're going to be looking at understanding how does, for example, the illumination of, say, mountains that are behind the lander when the lander is looking west of the sunset, for example, shown here, how is that illuminating the soil and bringing up added details, say, at looking at the regolith or looking at the rocks. Mm-hmm. This is not something we're used to seeing before, so now we're going to have to interpret these images against physical models of what we expect to see, as the sun is going down. I think that the images themselves are beautiful. They're really aesthetic. But I know there are a bunch of folks looking at them now that study the moon that are probably looking at them trying to figure out, well, how does that, what kind of model of light scattering or illumination behind me would, in effect, light up things in front of me while far ahead of me the sun is setting. Mm-hmm. So there's going to be a bunch of physical analysis, physics analysis and optics analysis that'll be done on that.
And
Adam?
Before we turn it over to you, I'll just say, we only saw the two images up front, but we have, multiple images at different points in time from different perspectives as well. So it's really going to take the suite of those images to be assessed to really get the pure findings coming out of that. And it's really hard to see in just the two we're showing today, but there's so much more we have access to and just need time to go through it.
Yeah. And then as to our probability of turning back on after lunar night, I think it depends who you ask, whether they're an optimist or a pessimist. I will say that the lander is absolutely not designed to live through the extreme cold that will occur during lunar night. And so I'd say the probability is very, very low that we do power back on. But this lander has surprised me multiple times over the last 2 months, and things have gone extremely well. So, I'll remain optimistic. Maybe we will get a signal, in early April, and we'll certainly let y'all know if we do.
Great. Our next question is from Marcia Smith with Space Policy Online.
Thanks so much. My question is for Jason. You've talked about other customers for these kinds of landers. What kind of cadence do you think that you could support? How many times could you launch per year?
Well, there's a lot of factors that go into that. Right now, we're expanding our Cedar Park spacecraft facility. We got a really hard-earned Texas State Commission grant to do so. And so we've already moved out, and Ray's going to get another clean room. So, I think at this stage, we're going to probably have 4 lunar landers in some type of life cycle in the high bay. But, we're always looking to grow and expand. And based on the demand, which I see the demand continue to grow, we'll make those kind of investments to enable the capacity that we need to, keep up with that demand. I can foresee 1 a year right now, but as we talk to more commercial customers in addition to NASA, it might grow to multiple a year. So we're looking at all those numbers and, doing our strategic planning based off of that.
And I'll just add, from a CLIPS perspective, we're still kind of working with the objective to award 2 task orders per year. Yeah. So that can also play into the story, but just wanted to add that point.
Thank you. Our next question is from Leo Enright with Irish TV.
Thanks very much. Question, I guess, for Joel Kearns. I'm sorry for beating this, but down to sort of the detail. But just to talk about this glow picture, the second image that was shown, can I just clarify that nobody is saying this is the glow that Gene Cernan described, the lunar horizon glow? I mean, this really does seem more like the coronal zodiacal light glow that's really well understood, and that it would take a lot more refinement to start drilling down into the sort of thing that Gene described, this long stretch of horizon glow caused by exospheric dust.
Yeah, I would say at this point, that now Blue Ghost has provided us this outstanding high-definition image, and now it's time for the specialists in the field to examine it and compare it to the other data we have on the mission and see what conclusions they can propose and draw from it. I think at this point, what we've got is a really beautiful aesthetic image showing some really unusual features, and the specialists have to really look at it and decide what conclusion they can draw from it.
Our next question is from Maneli Dekgarshani with The Other Side of Midnight.
Hi, thank you for taking my question. Following up, this question is for Joel, regarding your explanation of the lunar horizon glow as due to electrostatically levitated dust. So I'm puzzled that you insist on that explanation of the lunar horizon glow phenomenon seen by Eugene Cernan and perhaps also seen in these images that you just released, because NASA in 2013 launched a mission called the LADEE mission, which was specifically designed to test this hypothesis that lunar dust electrostatically levitated is the explanation. And on NASA's own website, what we learned from LADEE, that's the name of the website, it says one possible explanation for what the Apollo astronauts saw re-lunar horizon glow was that lunar dust, electrically charged by the sun's UV light, was levitating above the surface. However, the spacecraft's instruments found no evidence of any effect that could be seen by the human eye. So the question is, in light of these findings, which ruled out the levitating lunar dust explanation, shouldn't we just keep an open mind about what the explanation actually is?
Yeah, as a matter of fact, what I said in the beginning when the images were up was that was one model that's been proposed in the past. There are other, I didn't say this, but there are other models. For example, the measurements that you talked about taken by the LADEE investigation that was in orbit around the moon, not in the surface. And I think, again, that it's going to be up to the specialists that are working in that field to take a look at the imagery and the other associated data and draw their own conclusions.
Thank you. Our next question is from Manuel Manzanti with Exploración Espacial.
Thank you so much. Congratulations to both NASA and Firefly. Question about Lister, the drill. You mentioned that you could get up to 1 meter below the surface. Can you mention the temperature measures on that depth? Do you have any surprises there, or was it among the expected range? Thank you.
Adam, do you have anything?
I was just saying we can't. I don't have the data, and we can't comment on the temperatures. We just know that the data was taken going into lunar night. So we're going to let the Lister team go through their data and release what they want to release there. With respect to Lister, though, I will mention, if you haven't seen it, there is some great video of the operation that's on, I know, Firefly's blog, and I think NASA's released it as well. That's just spectacular. So, again, not directly answering your question, but I think for folks that haven't seen it, that's a very powerful video to go watch to see the actual operation, and very neat to see. So.
Thank you. It looks like we have time for one more question. Our last question will be from Will Robinson-Smith with Spaceflight Now.
Hi, thanks for allowing me to take one more question here. One to Jason, if I may. Going back to the business considerations, looking long-term, obviously the next couple of missions for Firefly with Eclipse are missions 2 and 3, and I imagine more beyond that to be announced, yet to come. But thinking about the greater lunar economy, how far out do you think it'll be before we see Firefly get to the point where NASA is not the main customer driver, but you either have them being a minority customer on a lander or a purely commercial flight with Blue Ghost? Thanks.
Well, I would just say that NASA is always going to be a big part of Firefly's business because we really believe in the NASA mission. And as Joel has taught me, science really pushes exploration, and exploration pushes science. And so we're going to continue supporting NASA as well as commercial, as well as national security. I think that I've always said to our Fireflies that we're a bold team. As long as we execute on our plans and do what we said we're going to do, we can go bigger and bolder. And, I'll find the support we need to grow our facilities, our equipment, our staffing. That's stuff we can do. So I just foresee us having a very balanced approach of supporting NASA, national security, and commercial going forward.
Yeah, I'll just add that it's always been Eclipse's objective to kind of not have the continued reliance all the way through. Obviously, some, as you said, but as you mentioned up front, opening that door real wide and demonstrated success is a real powerful thing, both for Firefly and for Eclipse. So, this is, as I also said earlier, this is just the early innings for Eclipse moving forward. So, we've just begun and really looking forward to what's ahead. Mm-hmm.
Thanks to all who submitted questions, and thanks to today's briefers for taking the time to discuss Firefly's historic moon mission enabled by the agency's Commercial Lunar Payload Services, or CLPS initiative. We hope you'll continue to follow along on Firefly's platforms and nasa.gov/CLPS. Thanks again for joining us. That will wrap today's briefing.